The next stamp, stamp 4, consists of exam review problems number 23 to 28. All right, for number 23, they're asking us to rewrite each equation in exponential form. All right, so they're giving it to you in log form. And remember, when we're moving from log to exponential form, we want to bring our base up and flip-flop our x's and y's. All right, so we can quickly do these problems, right? All right, now it gives us log base 10. It won't always say log base 10. It just will say log 1 over 10,000. All right, maybe. All right, so we want to bring our base up 10. All right, and flip-flop these two values. Negative 4 is equal to 1 over 10,000. All right, that'll be that one. The next one, bring our base up again, 6. Flip-flop your 216 and x. X is 6 to the x is equal to 216. All right, next one, well, here it is. Here they put the base 10, here they didn't put the base 10. But if it's a log problem, the base, if it's missing, the base is already 10. All right, so we bring our 10 up and we flip-flop our x and our 5. All right, and then natural log, well, that's what ln, everyone's like, well, why isn't it NL? Well, it's not. All right, natural log is represented as ln. All right, and the base for an ln is e. All right, it's an e there. Okay, so we're not bringing up a 10, all right, but we're bringing up an e. All right, we flip-flop our 7 and m, and so we end up with e to the m is equal to 7. All right, number 24. You have to do the opposite. All right, so for 24, they're asking us to rewrite each equation in log form. So before we were going log form to exponential. Now we're going exponential to log form. All right, so whereas we brought the base up, we want to bring the base down now. All right, and flip-flop. So 24a becomes log base 32 of 16 is equal to 4/5. All right, here, if I bring e down, it doesn't become log base e, it becomes, that's right, natural log of, and please don't write natural log of base e. All right, just natural log, that's what log base e is. All right, of 2 is equal to 3x. All right, and the last one, well, we bring the base 10 down. And we don't write the base 10. We go log. We know it's a 10 there already. All right. 100,000 is equal to 5. So we flip it. Done. Number 25 says evaluate each expression. We got a few rules and notes. I wish I had more space, so I don't right now. All right. We'll say log base b of b is equal to 1. So if we ever get these numbers the same, all right, then it's just going to be equal to 1. Log base b of 1. All right, anytime there's a 1 here, it's going to be equal to 0. All right, it comes from the fact that b to the 0 is equal to 1. All right, here log base b of x. This is the problem. You can always say b to the what power of x. B to the what power of x, and that what is what the answer is going to be equal to. All right, so that gets us started here. All right, so for what we're doing here, as my pen flies across the room, all right, is that for a problem like this, I think we started by putting a little box here. All right, and we kind of changed the problem around, or we said 3 to the what power will give us 81, which is 4, but if we didn't, we could change the form and make this 3 to the something power is equal to 81, and that something is 4. All right, another way to do it, all right, since you have a calculator, is to change this to a change of base problem. All right, now you didn't have to learn about change of base, and some students didn't, but if you do change a base, it will also give you 4. So either way, the answer is 4. All right. For this one, this is one of our rules. We see a 1 here, we should know that it's going to be equal to 0 because 23 to the 0 power is what's going to give you 1. All right, next one. Now, if you want to put the 10 in, you can. All right, but we're saying 10 to the something power is equal to 100 if we change the form. That something is 2. All right, changing base always works for that one too. All right, so we'll do these, change the way we do these a little bit. All right, we can put the box and we can say 9 to the something power is going to give us 3. All right, in this case, that's something. Well, it's not going to be like half or a third because it's an exponent, but we can say the square root, right? The square root of 9 would give you 3. All right, and how do we make square root an exponent? We make it by making it 1/2. So our answer is 1/2 here. If you don't feel comfortable with doing it that way, you can go log 3 of 3 over log 9. All right, that's that change of base. All right, again, for this problem, 2 ways of doing it. We can make the box and we could say 6 to the something power is going to make this equal to 1/6. All right, and that means we're flipping this thing. All right, how do we show a flip? All right, that becomes a -1. All right, so that's one way of doing it. The other way, you can go log parentheses 1 divided by 6 over log 6 in your calculator. All right, and either way you will get -1. All right, last one in this section. All right, put that box, and it's not very clear what the answer is. I know it's something dealing with base 2, but we're going to go log 4 over log of 8. All right, and so in that case, for problem number 25, we get 2/3 if we do it in the calculator correctly. All right. All right, for problem number 26, you might remember this problem on the test review. All right, very simple because everyone went, all the answers are X? Why is it always X? All right, and it's a simple rule that helps us to start to solve some of these problems. All right, where if we have b raised to a log base b of x, all right, this cancels, all right, and it's equal to x. They're inverses of each other. Same way, opposite of that would be log base b of b to the x. Well, they cancel, all right? So for all of these problems, all right, every time, what do you think happens? This cancels, this cancels. All right, this is remember, this is log base e of e to the x, so that cancels. All right, and the same thing here, this is log e of x. All right, so that cancels. So what's the answer for all of these problems? X. Done. Number 27. The graph below illustrates a relationship between the functions y is equal to 7 to the x and y is equal to log base 7 of x. What is the relationship between the two functions? Well, as we've gone along this school year, we've looked at functions where they've drawn this diagonal line, and if we take our head, remember we said tilt it to the right, we can see that the graph itself, and I can actually, instead of tilting it, I can bring that up. I can turn the graph, which I can't turn the Promethean board, and we can see that these two graphs are symmetric with each other, all right? And if they're symmetric with respect to this line, which we call y is equal to x, all right, they show symmetry, then that means that the relationship between the two functions is that they are inverses of each other. All right, they are inverses of each other, okay? Now, the graph, and so So when we look at explaining how the relationship is determined from the graph, all right, since the two graphs are reflections, or they are reflections or symmetric with respect to each other, all right, what we want to say is just basically what we said before, that they show reflections or symmetry. All right, reflections of each other with respect to the line y is equal to x. And that's all we want to write for that problem. All right, there you go. All right, number 28 reminds me a little bit of number 8, where there are a lot of problems to do. All right, we have 10 problems to do in this section, so let's get busy. All right, you guys want this video to be shorter than the other one. All right, in this case, all right, looking at the first problem, and we have to, as we go along, we'll start to remember our rules. All right, instead of equating the bases, we looked at numbers. We said, well, 2, 4, 8, 16. Y'all laughed at the whole 16, 2, 4, 8, 16, 32, so forth. All right, these are our base 2 numbers. All right, and 4 and 2 are base 2 numbers. Now, when we have base 2 numbers and we're doing this problem, we want to make it a log. We want to log base 2 both sides. All right, log base 2 both sides. All right, now if we do that, we're saying log base 2 of, well, we want to be able to change this 4. So we say log base 2 of 2 squared. That's what 4 is. And it had an x there. And that's equal to log base 2 of 2 to the 5th. Now, what can I do? I can pull my red pen out, all right, and I can cancel some things. I have log base 2 of 2, which means that on the right side we have 5, and log base 2 of 2 again, we have 2x. Divide both sides by 2, and x is equal to 2.5. All right, one down. All right, looking at the next problem, before we can start to log base anything, we need to get rid of this 2. So we're going to divide both sides by 2. All right, doing that, we get 5 to the x over 4 5 to the x over 4, sorry if you can't see it, is equal to 125. All right, so once again, throwing some numbers over here for this problem. 5 to the first, 5 to the second, 5 cubed. All right, 5 to the fourth. All right, those would be our base 5 numbers. In this case, 5 and 125 are there. So let's keep going. All right, we got a log base 5 and log base 5 it. All right, now from there, all right, I have log base 5 on this side, but I want to change 5 to 125 to 5 to the something power. 1, 2, 3. All right, so that's going to be, let's go ahead and write this all out. Log base 5 of 5 to the x over 4, and that's equal to log base 5 of 5 cubed. Now, what can I cancel? Some people say that this step is unnecessary, but we want to do it, all right, while we're doing this problem. All right, now that leaves us with x over 4 is equal to 3, and then we can finish solving that. Multiply both sides by 4, and x is equal to 12. All right, keep it going. All right, this one's a little bit easier. All right, might be a lot easier on us because there's not a lot to do here. Let's see. All right, I just wanted to rewrite the problem. All right, I want to get to this x, and the only way I can get to this x in the exponent is to cancel the 10. So we want to log base 10 it, or just log it. All right. All right. So in that case, this cancels. We have x is equal to log 40. Now, if you didn't have a calculator, you would be done. If you do have a calculator, you're going to go log 40. All right. And for this problem, you get approximately 1.602 as an answer. All right. All right. D. E to the x is equal to 9. So I want to get to this x again, sort of like I wanted to get to the x in C. All right, but I have to do the opposite of what the inverse of E, which is, you guessed it, the natural log. I don't know if you guessed it, but yeah. All right, in that case, my natural log of E cancels. I get x is equal to the natural log of 9. And in that case, x is equal to, if I round to 3 decimal places, 2.197. All right. Letter E. All right. I have 2 and 16. So once again, 2, 4, 8, 16, 32. All right. Those 2048 players, those numbers. All right. If you can play that, you should be able to know that both of these numbers are base 2 numbers. All right, so that means that we want to log base 2. Log base 2. All right, they're base 2 numbers. All right, and this side, it becomes, well, let's write it out. Log base 2 of 2 to the 5x is equal to log base 2. What is 16? 1, 2, 3, 4. 2 to the 4th. All right, now that'll allow us to cancel now. All right, canceling. All right, we end up with 5x is equal to 4. Divide both sides by 5. And x is equal to 0.8 or 4/5. All right. Next problem, the inverse of natural log is E. So we want to raise this whole problem up to an E. All right. If we do that, then our E and our natural log cancel. All right. And we end up with x is equal to E to the 8th. All right. And in that case, we would plug in our calculator, second natural log, 8. And enter. All right, and in that case, it would be, let me get these numbers out of the way, 2,980.958. All right, from here, G, H, and I. All right, first problem, well, we don't have to cancel a bunch. We just want to change the form. All right, 8 is a base 2 number, so we can write it as 8 base 2 of 2 cubed is equal to x. And in this case, this is just 3 is equal to x. Probably the easiest problem on it. All right, next problem. I have a 3 over here. I want to cancel that 3 by dividing both sides by 3. All right, the 3's cancel. I have log base 2 of x is equal to 5. All right, and now I want to get rid of this log base 2. So remember the problem where we're doing a bunch of canceling. All right, if I raise everything to a 2, the 2 to the log base 2 will cancel. Whatever I do to one side, you guessed it, I want to do to the other. All right, in that case, our 2 log base 2 cancels. All right, I have x is equal to 2 to the 5th. All right, and come on, 2048 players, 2, 4, 8, 16, 32. All right, x is equal to 32. All right, I might need those numbers again, I don't know. All right, so here's the thing. I want to change the form a little bit. I don't really want to cancel this, but I'm going to cancel. I want to get rid of the log. All right, I want to get rid of the log. There are a couple of different ways we can do this, but we're going to keep with what we've been doing. All right, we want to get that situation where we raise everything to an x. All right, now what happens here? X to the log base x cancels. It's just 64 is equal to x squared. Now we're back at first semester. All right, we want to solve this. All right, in this case, I take the square root. Square root, this would be plus or minus, right? Usually, all right? So we're going to write that first, plus or minus 8, all right? But here's the thing. You can never have a negative base, all right? And since you can't have a negative base, your only answer for this is x is equal to 8. All right, and J, last but not least, J. All right, we're trying to solve for x. We need to move things away. Now, I want to get rid of log base 4. So I push everything up to a 4. All right, that'll cancel that, right? All right, so this cancels. All right, we have x plus 9 is equal to 4 squared. All right, and that is a 9. Sorry if you can't really see that. All right, 4 squared is equal to 16. Subtract 9 from both sides, and x is equal to 7. All right, and I think that's it.